Hello everybody and welcome to another ATC Maths and Science tutorial video. Today we'll be dealing with the first of two rules involving triangles for grade 8 students. And that first rule is the sum of angles in a triangle equal 180 degrees, as we can see stated for us. So we've got a triangle drawn with angles A, B, and C in it. And if we add these three angles together, it should equal 180 degrees. Now, what else do we need to know in order to solve examples involving the use of this rule? And that would be some basic algebra on how to solve for x. So there will be the other videos. There's another video on how to solve for x in a linear equation. But for now, we're going to assume that you know how to solve for x in a linear equation. So let's get straight into the examples. So when we look at the first example that we get to see here, so let's just zoom into this example. And we can see that we have a triangle drawn with the three angles, one an unknown x, the other angle 40, and the third one is 60 degrees. And so we want to solve for x, as the question states, solve for x. So what will we do? Set this up as a sum. The sum of the three angles, x plus 40 plus 60, is equal to 180. We also put the reasoning alongside. Like, how did we come up with this statement or this equation? It's from the rule sum of angles in a triangle. We always state the reasoning alongside, as we normally have to do in geometry questions, right? High school. So from here, we can add our two like terms. 40 plus 60 gives us 100. Take the 100 across the equal to sign. The sign will change. X is equal to 180 minus 100. So x is equal to 80. The first example illustrating this. Let's do another example illustrating this basic rule. So here we're dealing with a right-angled triangle, as we can see. So we've got one angle to be 2x. The other one is 90 degrees, though they don't write the 90. They just indicate that right angle with a square box here alongside. And then the third and final angle in this triangle is 30 degrees. So setting up our sum, 2x plus 90 plus 30 is equal to 180. Reason again, sum of angles in a triangle. And adding the like terms, 90 plus 30 is equal to 120. So we have 2x plus 120 is equal to 180. Taking the 120 across, with dealing with the sign change as well. So we have 2x is equal to 180 minus 120, which would give us 60. So we'd have 2x is equal to 60. Divide both sides by 2, so that we have just the x. And so x would be equal to 60 over 2, which is 30. Now, there must obviously be examples that we're going to be dealing with that make this the use of this formula a little bit more complicated. And one of those concepts is isosceles triangles, as you can see in this third example. So what we must note is the following. We're dealing with an isosceles triangle. And usually in an isosceles triangle question, you can see the angle that's filled in here in purple. This is not written or not given to us. What we'll see is just this. Like they'll not have this. So we'll just have the triangle. That's all we would have drawn for us ourselves. And the 40 degrees would be missing. So we're expected to know that if we're dealing with an isosceles triangle, as we know, has two sides, two adjacent sides being equal. And so those two adjacent angles must also be equal. So all they give us in the question is x plus 10 as one of the missing angles and 40 degrees. We know we're dealing with an isosceles triangle, so we can fill in this 40 that was missing. Then from here, we can now set up our sum. X plus 10 being the first angle, 40 the second, and 40 again for the third. Adding them all together must equal 180 degrees. Again, our reasoning, sum of angles in a triangle. So 10 plus 40 is 90. So x plus 90 equals 180. Take the 90 across. X is equal to 180 minus 90. So x is equal to 90. So dealing with an isosceles triangle in there is just adds an extra step to what we have to worry about. So as we can see here, we get into another question involving this. So again, like usual, this wouldn't have been listed for us. This would not have been there. So we would have to have filled this in. We'd have to say to ourselves, okay, what's given to us? This is what's given to us in the question. It's just the triangle. They give us 40. They give us x plus 10. But this is an isosceles triangle. So if this is x plus 10, this must, 2x plus 10, this must also be 2x plus 10. And so now we can set up our sum. 2x plus 10 for the first angle, 40 for the second, 2x plus 10 for the third. Adding all our equal to 180. Adding our like terms together, 2x plus 2x is 4x. 10 plus 40 plus 10 is 60. Take the 60 across. 4x is equal to 180 minus 60. So 4x is equal to 120. Divide both sides by 4, and we will end up with x is equal to 30. So that's what having an isosceles triangle does in terms of dealing with an extra complication that exists. So now we get to the fifth example. And the fifth example is illustrating for us this point that sometimes we don't have to give you values for two of the angles. We can actually have everything in terms of x. And we still have to be able to solve this using the same method. So in this fifth example, we have one angle to be 4x, another one to be x, and then the third one to be x plus 30. So when we add these three angles together, x plus 4x plus x plus 30, it must equal 180 degrees, sum of angles in a triangle. Adding our like terms, we have x plus 4x plus x gives me 6x plus 30. Take the 30 across, 6x is equal to 180 minus 30, which is 150. Divide both sides by 6, and so x will equal 25. Now you notice that I also filled in the values here alongside the triangle, 25, 100, 55. Occasionally, there'll be an added on question where they'll say to you, okay, find the exact values of each of the angles. Now, we know x is 25. So that means this angle at the bottom of the triangle must be 25 because that's x. This angle is 4 times 25, so it'll be equal to 100. And the third angle would be x plus 30, so it's 25 plus 30, which is 55, and that's the exact values of each of the angles there. But this is the basic use into the sum of angles in a triangle. So below we have some exercises. You can always pause the video to solve each of these questions. The solutions are listed alongside in this exercise. The first one shows the solution for how to solve for x. I suggest that you pause the video, take down the question, and always come back to take a look at the solution, because it's always good to practice maths as a subject that we learn through doing and not just watching. So that's the first question where you have to solve for x. The second one is one where you have to solve for both x and y, and it's got an isosceles triangle in it as well. The third question combines solutions to triangles with, because these are all exam level questions, with parallel lines. And so if you need a refresher on that, you can always check out one of our videos here at HTC Maths and Science on how to deal with parallel lines and the rules there. So you'll find that when you get to an exam, they'll often combine this section with parallel lines. So that's the third question coming out here and solution. And then finally, we get to the fourth question, which is, again, parallel lines and multiple triangles for us to deal with. Here we have to solve for A, B, C, D, and E. So just scrolling down so that you can see all solutions and how you get it. Suggest you pause the video, take down the question, and try it for yourselves. But thank you for watching this video lesson on the sum of angles in a triangle. Please don't forget to press that like, share, and subscribe button. It would really help the channel out. Thank you for watching.